Hi, welcome to Earth Gravity. In this session, we will be learning the basic concepts of light. Now, first of all, let us see what are the things we are going to find in this session. In this session, we are going to learn about what is meant by light, what are the definitions of ray, beam, pencil, the definitions of convergence and divergence, what are luminous bodies and non-luminous bodies, sources of light, and then the intensity of light and its units, shadows, types of objects and images, properties of light, laws of reflection, and laws of refraction. Now, start going to the session. First of all, let us see what is meant by light is. Light is a form of energy. Light is a part of an electromagnetic spectrum. Now, what is electromagnetic spectrum? So electromagnetic spectrum is a range of all types of electromagnetic radiation. Again, a new word, radiation. Now, what is radiation? Radiation is the emission or the transmission of energy in the form of waves or particles through space or through a material medium. So electromagnetic radiation such as radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma radiation are a part of electromagnetic spectrum. Now, let us see how the electromagnetic spectrum would be. So this is a image how the electromagnetic spectrum, that is, I am giving here the values or the frequencies and wavelengths of different parts of light, what we are able to get. The light which we are able to get, or that which is a electromagnetic spectrum, in this spectrum you are able to see different kinds of things. That is gamma rays, X-rays, ultraviolet, visible, infrared, thermal layer, microwaves, radio, TV, long waves. So these are the different parts of electromagnetic spectrum. Here we are able to see a certain part called the visible light. So at the top of this scale you are able to find the frequency, and at the bottom you are able to find the wavelength. The visible light is between 400 nanometers to 700 nanometers of wavelength. Now here you are able to see beneath the visible light, you are able to see something as the infrared, and at the top you are going to see the ultraviolet. So these are the ends of the visible light. Okay, now let's go back to the main theme. Now here we are going to see different kinds of way of representation of the light. Light is also called as the light energy emitted by excited atoms or molecules can cause a sensation of the light, or it's a vision, the sensation of the vision. Light bounces back from the surface of the object. So whatever be the object, we are able to see it's only due to the reflection of the light from those surfaces. Now light is a form of energy which is emitted by luminous bodies, and when incident on the eyes causes the sensation of the light. So here you are going to see certain kind of new words like the luminous, incident. Okay, so what are these things? So we'll be learning in the coming session ahead. Next, light has a dual nature, that it has both the particle nature, that is ray nature or the particle nature, and also a wave nature. Now let us see some of the definitions that we are going to make use in this session. Ray. What is a ray? The path along which the light travels is said to be ray. It is represented by an arrow. So arrow is going to indicate the direction of the travel. Next is a beam, a collection of rays. So bundle of rays is called as a beam. This is the bundle of rays which we are going to call as a beam. Next we have something called as the pencil. A narrow beam of the light is called as the pencil. Okay, so mostly we'll be able to mention it when you are studying about the refraction. Now we have something called as a convergent and divergent. First of all, what is meant by convergent rays? Convergent rays are the light rays from different points which tend towards a single point. They are going to move towards a single point and they are going to meet at a point. Whereas the divergent rays are the light rays which start from one point, travel in a different direction. From that point they try to move in different directions. Now let us see the figure and what all. Now this is a picture or the figure that is demonstrating about the convergent beam. See, you are able to see three different rays coming from different points are going to meet at a certain point. Okay, so that's a point of convergence or the convergent beam of the light at that point. But after that, all the three are leaving from that point. So that can be said as a divergent point. Okay, now when the rays of light coming from different directions are meeting at a point, then such a collection of rays is called as a convergent beam of light. Next, the divergent ray. Now here you are able to see that they are moving away. So when the rays of the light are coming from such a point in various directions, then such a collection of rays is called as a divergent beam. Here you are able to see that the rays are coming from a point and they are moving away in different directions. What is the source? The object that can give the light is called the source, and it is called a source of a light. Now the light can be classified into two, that is the luminous bodies and non-luminous bodies. The luminous bodies are being classified again into natural luminous bodies and artificial luminous bodies. Natural bodies, they come as sun, stars, glowworms. But when it comes to the artificial, candles, electric bulbs, oil lamps, torch, hurricane lamps, etc., they come under the artificial luminous bodies. Let us see what is the actual definition of luminous bodies. Objects which give out or emit the light energy by themselves are called as luminous bodies. That is, the sun, it can give off its own light. It's not going to depend on any other thing. The stars, so they to give off their own light. They don't depend on other things. Now coming to the non-luminous bodies, the objects which do not emit light energy of their own but reflect the light falling on them and they are visible. So most of the things what we see around us are non-luminous bodies. The light is going to be falling on them and we are able to see the things around us. So that's what the sensation of vision is. One such best example what we see in the night time is a moon. So moon does not emit light by its own. It reflects the light. That is, the sunlight falling on it is being reflected and we are able to see the moon. So moon does not has its own light. It comes under non-luminous bodies, not as a luminous body. So the intensity of the light always depends upon the source of the light. The candle intensity of the light is more than the glowworm. Similarly, the electric bulb intensity is more than the candle. Now, if you are able to see intensity of light of a glowworm, it would be less in comparison to that of the candle. Similarly, an electric bulb would be more, intensity would be more than that of the candle. The intensity of the light produced by a source light is compared with that of a candle. The brightness or luminous intensity of a source of a light is measured by comparison to the brightness of the candle. Now electric bulbs, mostly they are rated as candles or watts. Now why if you are making use of these candles? At present you will not be able to find, because in olden days we used to have those electric bulbs which are rated on it as 60 watts or 60 candles or 100 candles. Now what does it mean 100 candles? 100 candles means burning 100 candles all at a time. The amount or the intensity of light that is being given, or at present we are making use of the LEDs and CFLs. Even CFLs are also not being seen nowadays. All of them are replaced by LED. Okay. Now the unit of intensity of light is called as the candle power. The modern unit of intensity of light is lumen. Next, 1 lumen is equal to 12.56 candle power. Now 1 watt is equal to 700 lumens. Now the rate of the bulb rating is given in terms of watts or candles, as a 15 watts LED or 28 watts LED. So these are the units that are you able to find on the bulb. So 1 watt is equal to 700 lumens. Next, as the distance from the source increases, the intensity of the light decreases. So it is one of the important points that should be kept in mind. Now let's see with the help of a small activity how it is going to be. Now here is a setup where you are able to see 4 cardboards of the same dimensions and having a pinhole at the same height for all the 4. And they are placed on a table, and I'm making use of a candle as a light source. Now I make the room dark. The intensity of the light falls on another sheet of white paper placed at a distance. As I'm going to take off these sheets, the distance is going to increase from the light source to the last cardboard. So the distance is increasing. At the same time, you'll be able to see the intensity of the light is decreasing. One practical example is take a torch and let it on or switch on the light or place the light source onto a wall which is near to you. You can see very bright light. Now focus the light onto a longer or a larger distance point. You will not be able to find the same intensity of the light. So as the distance is increasing, the intensity is going to decrease. The intensity of light at a place is measured in terms of lumens present on unit area. The unit of intensity of light at a place is measured by foot candle, and lux is a modern unit of it. Next, 1 foot candle is equal to 10.76 lux. Please don't get confused with the units. Now let us see the classification of matter. As per the light is concerned, I can classify the matter into 3 types. That is the transparent, translucent, and then the opaque substances. Now what is a transparent substance? A substance that allows the light to pass through them or which helps in propagation of the light through them is called as transparent substance. Example, the transparent glass or a plastic sheet of paper. So such kind of things where you can see the other end of the objects clearly, we call as transparent substances. Coming to translucent, the substances which do not allow the light to pass through them. When it comes to translucent, the medium or the substance which allows only a partial amount of light to pass through them, we call them as translucent substances. Example of a paper being oil, or if you think that paper has got some kind of oil stick to it, if you observe, you are able to see only partial light. You even have certain kind of glass panes that are used for your windows. Coming to opaque substances, the substances which do not allow the light to pass through them, we call them as the opaque substances. Opaque substances are just like your table, your wall, books, whatever it may be, which do not make the light to pass through them. We call them as opaque substance. Now what is a shadow? The shadows are formed when an opaque body is in the path of the beam of a light, which proves the rectilinear property of light. We got a property called the rectilinear property. We'll shortly see what it is. What are shadows and how are they formed? Now let's go over a small figure. So in this figure, you are able to see a car is placed and the rain is falling on it. Now let us consider a person came to your house in a car and he placed in front of your house and he got in and he was speaking to someone else for a few minutes. So meanwhile, it started drizzling outside. So you are able to see that the complete area has become wet. The person who came left your house through a car. Now the car has left that place. You are able to observe a patch in the shape of the car which is dry. The remaining part is wet except the area where the car has been parked. Why? Why is that area dry in comparison to the other area? Because raindrops are unable to penetrate or pass through the car and make the area wet. So the car is not allowing the raindrops to pass through it. As a result, patch is dry in comparison to other. As soon as it leaves, the rain falls and it becomes wet. Now compare it, the raindrops to that of the light. So when the light ray fall on an opaque object, it does not allow the light to pass through it. As a result, you will not be able to see the light beneath it. The remaining area surrounding it would be covered with the light because the light can penetrate through that area. But when it comes to opaque substance, it does not allow the light to penetrate through it. So that is causing the shadow. Hope that would be understandable. Now let's see what are the types of objects. We have 2 types of objects called as a real object and the virtual object. Let us think that a light is coming from an object. One thing we have to keep in mind is that from a source, the light travels in all directions. But for our study purpose, we are just going to take 2 or 3 rays of those infinite number of rays. So here I am going to have a real object and I am just taking 2 rays that are coming from the real object. So here, if 2 rays or more incident rays seem to emanate from a point, means start coming from a point. then that point is called as a real point object. Now here from the real object you are able to see two rays are coming and they are falling on optical element. Now what is an optical element? Optical element can be any plane mirror, plane glass, concave mirror, concave lens, convex mirror or convex lens, whatever it may be. That is the optical element. Now how about the virtual object? So in a virtual object, let us think that two rays are moving in their own path. I brought in the middle of their path an optical element. We will not be able to see whether they are going to meet or not. But if I am going to extend those lines beyond the optical element, they would be meeting at a certain point. I don't know where they are going to meet, but I'll not be able to see. The point where they are going to meet, which can't be seen, we have to assume. So such a point or such an object is called a virtual object. So if the rays are intercepted by an optical element, here they are intercepted by an optical element. These two rays are intercepted by an optical element as shown in the figure below. This point of convergence is a virtual point. So the point where they are going to meet, converge is to meet, are going to meet at a point. So such a point is called a virtual point. Now coming to types of images, here also we are going to have two things called as a real image and a virtual image. So real image is an image when formed by the reflected or refracted rays where they are going to actually meet or converge. So here is a real object and here the two rays are coming off from the real object, and here at the center I am going to make the plane mirror. So when incident rays are coming from the object and falling on the plane mirror, they are reflecting back. Okay, but if I am going to extend the reflected ray, that is this ray, if I am going to trace it back, it is going to come to up to this point. Similarly, the second ray, there can be any numerous number of rays that are reflected, but if I am going to trace back all the reflected rays, they are going to meet at a point. So the point where they meet is called as a virtual image. The virtual image is formed when the light rays appear to emanate from a point but do not actually meet. Here they don't actually meet, but we are assuming that they are going to meet. Here are some of the important properties of the light. They are, the first one is rectilinear propagation of the light. Now here the word rectilinear, it has the word called as a linear line. Line is going to be 180 degree. It is going to be straight, no bends, nothing. So the light here moves similarly in a straight line. The name itself indicates. So the property of the light propagating in a straight line is called as rectilinear property. Now with this in this image you will be able to understand the rectilinear property of the light. So here the candle is placed right and all the four cardboards are in line with the candle. Now the light has been able to pass through the pinhole from one cardboard to another onto the screen. Now let us assume that if I am going to lift the second one a little bit higher, the light will not be propagating or the light will not be falling on the third or fourth or on the wall. Why? Because the pinhole of the second one is not in alignment with the first one. So the light cannot pass through. It is acting as opaque. So as an opaque substance, it does not allow the light. So light is not reaching to the other one. Now if I am going to bring it down, again you are able to see the light on the wall because it is able to pass the light through the hole. So we can say that with this activity that the light always moves in a straight line. Now one more important property is reflection property. Now here you are able to see that I am going to make use of a surface, the glass medium or a smooth surface is being here. Now the rays that are coming from the source are called as the incident ray, I know it. Now when these incident rays are falling on the surface and they are moving back or bouncing back to the again to the air medium. See, they are coming from the air medium, hitting the surface and moving back to the air medium. The property is called as a reflection. That is, when the light rays strike the boundary of two media, a part of light is turned back into the same medium. Then such a thing is called as a reflection property. Next is a refraction. In this refraction, you are able to see two medium, that is air medium and the glass medium, or it can be water, whatever so it may be. The air medium is called as a rarer medium, that is a thinner medium, whereas the glass or water, it is a thicker medium called as a denser medium. So here you are able to see the incident ray on reaching the interface of the two medium, it started bending while it is traveling in the glass medium. So when the light rays are traveling in one medium, enter another medium, they bend at the surface of separation due to change in its velocity. So the velocity of the light ray changes as there is a change in the medium. When you're moving from air, it would be very fast, but when it comes to glass medium, it would be very less. The velocity decreases. So for example, take that you are riding on a bike and coming on a smooth surface. In between the tracks of your tires, air is easily entering and moving freely. All of a sudden, you will be able to observe a sand in your path. But the moment you enter the sand, the velocity of your vehicle gets decreased. You slowly move and try to come out of the thing. As soon as you come out of the sand, again your vehicle picks up its velocity. That's the same thing that is happening over here. You can understand better when it comes to the simulation part of this one. Here is a simulation that is going to represent about the properties of the light. Now here let me explain what are the things that are available in the simulation. Now at the top left corner you are able to see called as a ray and a wave. So which means that we know that the light has a dual nature. It has both the particle nature, that is a ray nature, as well as a wave nature. So that's the thing. Next, at the other end you are going to have the protractor to measure the angles, the intensity meter to measure the intensity, the speed, etc. And this is the source from which you are able to get the light. So that's the source of the light. Next, on the other hand, you are going to have the medium for this two medium, that is the white one is one medium, whereas the purple, light purple one is going to be another material. Now let us start about it. Now I am going to take the protractor, I am going to place it at the center. Now I am going to switch on the source of the light. So let me keep it the point where both of them are, let it be the point of the center, right. I am going to include a normal. So we know that from the law of reflection that the angle of incidence is going to be equal to the angle of reflection. So the incident angle, that the incident ray is coming from the source. So this is the incident ray, and the one that is leaving is called the reflected ray. Now the angle of incidence, that is the angle between the incident and the normal, is called as the angle of incidence, whereas the angle between the normal and the reflected ray is called as the angle of reflection. Now we know that angle I is equal to angle R, that is angle of incident would be equal to angle of reflection. Now if I am going to change it, you can see both of them are going to have the same. Now if I am going to put it at a 60 degree, now it is also going to have the sum 60.1. So both of them are going to be equal, right. Now there is one more property of the light that is called as a refraction, that is the bending of the light ray. So here you are able to see this is a reflected, and this is the one that is getting down to the another medium is said to be the refracted ray. Now let me measure. We know that the bending of the light ray is mainly due to change in its velocity of the light ray. Now let us see what is the speed of the light when it is in the rarer medium. Here the rarer medium is air is a rarer medium, whereas the glass here at the bottom is the denser medium. Let me change from the glass to water. Okay, now water is a denser medium. Now let me bring out the speedometer. Let me check what is the speed of the light over in the, let us check the speed of the light from the incident point. So it is going to be 1 c. C is the unit that is we call as speed of the light is measured by c. Okay, to represent speed we make use of the letter c, E equal to mc square, where c is the velocity of the light. Now when it comes to the reflected ray, it is also going to have the same speed because both of them are in the same medium. But when it comes to the refracted, the velocity of the speed or the speed of the light has been decreased to 0.75 c. That is, there is a decrease in the speed of the light. Now if I am going to reverse the thing, let me check it out how it is going to be. Now how about it? Now there is an increase in the speed when it is in the rarer medium than in the denser medium is 0.7 c. Reverse is the aspect here. So the velocity changes when it is moving from denser to rarer or rarer to denser medium. Similarly would be the intensity of the light. So the intensity of the light is 100%, but when it comes to here it has decreased. So the intensity decreases. Okay. Now let us see what happens if I am going to increase, let me increase the angle of incidence and what it is going to happen. So now at this point when I increase the angle of incidence, I am unable to find the refracted ray. I am able to see only the refracted ray but not the refracted ray. I am able to see only the reflected ray. That is now it is said to be in total internal reflection. Internal means within. So here the light has undergone a total internal reflection. So the angle at which it goes, the total internal reflection is called as the critical angle of that medium. So here it would be around 48 point some value, around 6 or 8. It would be the critical angle of water in this scenario. Okay, now if I am going to decrease, so now you are able to observe the refracted ray. Now check one thing, the angle of incidence in both the cases, that is angle of incidence and the angle of reflection here is the same, that is it is somewhat less in comparison to the angle of refraction. Okay, now if you are able, one thing, you observe one thing, that when the light is moving from denser medium to a rarer medium, the angle is 67.2, that is the angle of refraction, the angle between the reflected and the normal is 67.2 degree. But now let me reverse. What happens? I am not going to disturb anything, I am just changing the medium. Now check it out what the angle would be. Now here you are able to see, though the angle of incidence and reflection are the same, but you are able to see a decrease in the angle made by the refracted ray. That is, again there is a decrease. So one thing we can infer is when the light is moving from rarer to denser medium, the refracted ray would be towards the normal. This is a normal. The line that is on the zero of the protractor here is the normal. So here it is towards the normal, but in the opposite thing, that is when I have changed it to the water and air, that is when the light is moving from denser to rarer, the angle is moving away from the normal. So this is a very important thing, and most people get confused when it is being asked in the bits or for a problem. So keep in mind, try to have a short code so that you can clearly overcome the confusion. Other properties which include, these are not being discussed here, but in your higher classes or in further sessions you will be able to learn these things. They are the diffraction, dispersion, interference, polarization, scattering. So these are some of the important properties of the light. Next, kinds of reflections. The surface which reflects most of the light falling on it is called a reflecting surface. Keep one thing in mind, that we are going to make use of the terminology in most of your answers or while expressing your views as per the subject is considered. Terminology is the most important thing. So keep that in mind. Try to remember what the terminology is, where to use and how to use. Without the make use of terminology, you will not be able to score the marks. Keep that in mind. Now, reflecting surface. The surface which reflects most of the light falling on it is called as a reflecting surface. So you will be making at your houses, you will be able to see your floor. It will be reflecting the light. So it's a reflecting surface. Similarly, a glass. So these are all the examples of reflecting surfaces. Now, there are two types of reflecting surfaces called as regular reflecting surface and irregular reflecting surface. Let us see first of all the regular reflection. Now here is an image where you are able to see a smooth surface like a glass. The air from air medium, you are able to see the incident of light ray falling on the smooth surface and it is bouncing back to the air medium. So the reflection which takes place when the light falls on a smooth surface and polished surface is called as a regular reflection. How about irregular? Now here you are going to observe an irregular surface in the second figure. So though it is a glass, it has irregular surface. Now, it is going to have the same incident ray as in the earlier smooth surface. But see what is happening after reflection. The reflected ray are distorted and they are moving as they like it. So the reflection is completely based on the point of incidence. So if the point of incidence is right, okay, they are going well. If there is a curve or a dip, there shall be a change in the reflection of the light ray. The reflected ray is going to move in a different direction. So the surface, if you're going to have irregular surface, you're going to have irregularities. So the reflection which takes place when light falls on a rough surface is called as irregular. Now, collective effect of the various reflected rays from various points of rough surface constitutes scattering of light. A word scattering which I've seen earlier when I talked about other important points. So the light is going to get scattered more, that is, it means go here and there. As soon as a long bell of your school rings, you scatter here and there. So that's a scattering. You don't follow a line. Now, let us see laws of reflection. Now, here is a figure. So in the earlier, we have seen the simulation part where you have came across this kind of thing. So here you are able to see the incident ray, the ray that is coming from the source, the reflected ray that is leaving the surface, and the normal is the that is perpendicular to the surface is said to be a normal. So I call it normal ray. Now the angle between the incident ray and the normal is called as the angle of incidence or incident angle. Similarly, the angle between the reflected ray and the normal ray is called as a reflected angle or angle of reflection. The angle of reflection would be equal to the angle of incidence. Now there are two laws as per your context is considered. But in the earlier old textbooks, we used to have the three law. That is, the second law would be of a similar thing, but the representation is in different way. Now let's see. The first law states that the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. Now you're able to see if the bottom of the surface is, look the pointer, this is one surface, the top one is one more surface. Now the incident ray, the normal and reflected, they are on the same plane. They are not on the other side of the thing. They are not towards us. They are on the opposite side of us. So all of them are lying on the same plane. So the incident, the reflected and the normal all lie on the same plane. That's the first law. Coming to the second law, this is not there. The incident ray and the reflected ray lie on the either side of the normal. So this is a normal, and to either side you are able to see the incident ray on this side and the reflected ray on the opposite side. Now this third law, this is what you are going to have. You don't have the second point in your textbook. You have the first and the third law as the first and second law. The angle of incidence is equal to angle of reflection. We have seen it in the earlier simulation part that the angle of incidence is equal to angle of reflection. How much is the angle of incidence? That much would be the angle of reflection. So this is the third law, or as per your context is considered the second law of reflection. What is meant by angle of incidence as per the definition is being considered. The angle of incidence is the angle between the incident ray and the normal, and it is denoted by angle I. Similarly, the angle of reflection is the angle between the reflected ray and the normal, denoted as angle R. Now we have one more law, just like the laws of reflection. We have the laws of refraction also, sometimes referred as Snell's laws. So the first law states that the incident ray, the reflected and the normal to the incidence of any two given medium lie in the same plane. A slight change to what you have studied in the first law of reflection. You studied there the incident ray, the reflected and the normal lie on the same plane, but here you are able to see that the three lie at the interface of any two given mediums. They lie in the same plane, similar one. Thanks to the second law states that the ratio of the sine of the angle of incidence and sine of the angle of refraction is constant. So in the earlier we have seen that the angle of incidence is equal to angle of reflection, but here you are going to see ratio of the sine of the angle of incidence is constant with the sine of angle of refraction. Let's say that the ratio of sine of the angle of incidence and sine of angle of the refraction is constant, that is n1 sine theta 1 is equal to n2 sine theta 2. So these things we will be studying in the higher classes. Those who are 10th, they would be able to have an idea what it is. So sin I by sin R is equal to n, where n is the refractive index of the denser medium. So this is what the laws of refractions are. So in the next coming class, we shall be learning some more important and interesting topics of the light. Thank you.